we want to find delta G of the reaction for the following reaction. So they've given us what we need. And they want us to use these reactions with these provided delta G's of the reaction. Now, if you kind of think about this, should remind you of when we did Hess's law back in General Chemistry 1. What I want to do first, I'm going to number these equations because remember you can only use each equation one time when solving. So the easiest way I find is to write down what exactly is I want. I know it's right up here, but I want to make sure I can see it. So this is what I want. I want N2O gas plus NO2 gas yields 3NO gas. So that's what I want. So most of us read from left to right. So I'm going to start with the first one. And if I look, I want to find an N2O. Now, which one of these equations do you see an N2O in? Well, I see one right here in number 3. Now, the problem is I need that to have a coefficient of 1. Well, what would I divide 2 by to get 1? I would divide by 2, so I'm going to take 1/2 times number 3. And when I do that, that's going to give me, now remember we're doing this line up here, so I'm going to go ahead and do it in another color so you can see it. It's going to give me N2O gas yields, now 2 divided by 2 is 1, so I've got N2 gas, and 1 divided by 2 is 1/2, so plus 1/2 O2 gas. Now, whatever you do to the equation, you also have to do to the delta G of the reaction. So over here, I'm going to have 1/2 times minus 207.4. Okay, so we've used number 3, so it's gone. We can't use it again. Now, the next thing I see is I need an NO2. Well, the only one that has an NO2 is number 1, but, oh man, it's on the wrong side. So remember, I can reverse the equation to get it on the correct side, and I need to have a coefficient of 1, so I'm going to multiply by 1/2 for number 1. I remember reversing it and multiplying by 1/2 at the same time. If you need to break those apart, please do. Since I know that in my courses I covered this in Hess's law, hopefully you recall this. So that's going to give me 2 divided by 2 is 1, so that's going to give me NO2 gas goes to 2 divided by 2 is still 1, so I've got NO gas plus 1 divided by 2 is 1/2, so I've got another 1/2 of O2 gas. And then if you take the reverse, I'm going to take it a minus. It's going to be 1/2 times that value, which is minus 71.2. Okay, I've got that. Now, I didn't do anything to number 2, correct? So I'm just going to take number 2 and I'm going to rewrite it down here. And that's going to be N2 gas plus O2 gas goes to 2NO gas. Now, you might be asking, well, if she didn't use it, why in the world do I need to rewrite it? Well, remember the instructions said we have to use all of the following. So if you don't make any changes to it, you still have to include it in your calculations. Now, what I want to do is I'm going to add straight down or straight across, however you want to think about it. And I'm going to go ahead and I'm going to write every term that I see on the left in these 3 equations that we did and every term on the right. So I get N2O gas plus NO2 gas plus N2 gas plus O2 gas. So that's what I have on the left. Then on the product side, I've got N2 gas plus 1/2 O2 gas plus NO gas. You knew I was going to run out of room, right? Plus 1/2 O2 gas plus 2NO gas. Now, first we need to make sure that that's correct. So anything that looks exactly the same on both sides, I'm going to cancel. So I see an N2 here and an N2 here. Half an oxygen and half an oxygen is a whole, so that's 1 and 1. And I don't think anything else cancels, right? So now I want to write everything that's left over. Got N2O gas plus NO2 gas yields, and then I've got NO, that's a funky looking O. Let's try again. NO gas plus 2NO gas. Oh, those look the same, right? So I should have combined those into 3NO gas. Now, does that look like what I wanted? Well, that's the same as that. That's the same. 3, and now that I combine those are the same. So what we did was correct. Give yourself a pat on the back. And now I need to add up everything I did over here on the right-hand side. So this part right here, we're going to add together. And when we do that, we get a positive 107.1 kilojoules.